Okay, some minor tweaks then. Let's get across to Cura to start with. So I've been experimenting with some of the settings. This is the ini file for the P51 Mustang, and the ones that I've been messing around with were around printing temperature. So I've increased the bed temp to 70 Celsius, left the flow rate around 104. Printing temperature really depends on the material that you're using. I'm currently using a PLA. It seems to be happy at around 200 Celsius. As we're doing aileron parts and elevator, we're now using a top and bottom pattern of zigzag. You can use different formats, but really zigzag seems to be the best. If you were doing circular stuff, maybe concentric rings, and you can experiment with the different types, but in terms of structural integrity, strength, zigzag works quite well, especially when you're looking at these parts down here, and because these bottom layers are slightly thicker to support this control horn for the aileron. As we're doing control surfaces, so we've got bottom layers set at 8, bottom thickness of 2 millimeters, top layers of 2 in this example, because there is going to be a top layer here. And you can again play with the top and bottom thickness. We're still using a layer height of 0.25, a wall thickness of 0.4, and a wall count of 1, because we're using thin wall printing for the actual surface, the control surface. All the usual settings apply. Print speed, I'm experimenting with a slightly faster print speed. Combing remains off for this one, but I have enabled Z-Hot Retract. Don't really need it for this part, but as I'm going to be printing out multiple parts, this is just a test piece really, just to establish the strength and integrity of this control horn down here and the bottom layer. So sometimes it's good to print out one part, test the strength, integrity and everything else about the material flow, just to see if it works okay. There is no real support required for this. Switched on or not, it's not going to make a difference on this part. We're using a skirt, and you can see the skirt around the edge here. Because the control horn itself will be squished down, it's providing fairly good bed adhesion. But if this were thin wall printing, with no kind of control horn, nothing in other words to keep stability, it'd be a good idea to add a small brim, and the brim will then attach to the base of the surface. And that's what I've found, especially with the wham bam build plate, or if you're printing on glass. But again, that's all down to experimentation with your printer. Because if you do get a bit of snagging where the print head clacks, and you can hear it sometimes on the Z-axis where you hear a clicking sound, it's quite possible that as the object gets taller, it can actually topple it and snap it off the build plate. Which it did on one occasion on a very, very tall fuselage part that was thin wall. It just knocked it off at about 70–80% up and effectively ruined the part. Everything else is set as normal for thin wall printing and Cura for this 3DLabs part. Surface mode is normal, slicing tolerance is set to exclusive, and all your mesh fixes 0 and unmarked. Once that is done for this particular one, then you simply save to a file. Alright, and you'd save it away, whatever. Now what I've been also doing is messing around with the G-codes, because there is talk within the how-to guide from CNC. Remember, I may have mentioned CNC Kit, well I did mention CNC Kitchen before, and he does talk about the settings for fuselage, wing settings, and for the control surfaces, and it's well worth listening to some of these, and especially where he talks, I think it's early on, where he talks about the G-codes in here. About here, look, you can see he's talking about G-codes, because if you wanted, for example, to use G-codes, so you've outputted the file into a G-code, or you want to take existing G-codes, then you can actually set the extrusion rates within here. So for a Bowden system, remember, we're typically using a retract of about 4 millimeters. With a non-Bowden system, they're leaving it at about 0.7. So the G-codes that come with the P51 Mustang direct from 3DLabs, these G-codes are modeled in Simplify 3D, and they are set by default to use a non-Bowden. Means the Bowden tube that connects into the hot end. So they've got a printer that they're using, which is not using a Bowden. Now with a Bowden, because you've got friction within the Bowden tube, you've got to actually add much larger amount of retraction to stop all of the stringing that exists between the different components. You don't want the stringing, you want nice clean prints. Just like they show in this video, it's immaculate. There are no stringing. This is using an Ender Pro S, and it not only is it clear walled, but also where it's going into these sections that are providing rigidity to this thin wall structure, there is no stringing. So that is a pretty darn good setup on that particular printer. Whereas I'm using the Anycubic, and I've yet to get perfection in terms of, you know, getting rid of stringing or whiskers, and you have to mess around with the extrusion settings. Now you can either do that in Cura by playing around with both the temperature, the bed temperature. Bed temperature is quite important, especially if you're moving between a lot of objects on the bed. You want all these objects to remain at a decent temperature, so that when you return the head to these components, they're nice and warm. All right, and therefore the material flow will be good, because you'll get good adhesion between, as it goes back and forth between the different objects within the bed. But the downside of printing multiple objects on the bed is that you will get whiskers that can go between the different objects, and so you have to mess around with your build plate temperature, your flow rate, your retraction. So I've set, the retraction distance. So for a Bowden based system, it's anywhere between 4 and 6 millimeters. So you might want to experiment, start with 4, see how it works out, then inch it up, or millimeter, 0.2, etc., until you find the ideal rate. In terms of retraction, action, prime amount, what that means is that you retract when you move between the objects, or if you're Z hopping as well. Your Z hopping means you're lifting up the head and moving to a point within the object. What you can do is then prime the head, effectively you're pushing filament back into the reservoir, and you can experiment with this value here to get that effectively a pump effect by pushing the filament back into the reservoir and re-priming it. This is what retraction extra prime amount actually means. It's a funny term, but that's actually what it means. And again, you can experiment with all of these settings and the print speed to get the desired behavior. Now these seem to work fairly well for an i3 printer, but you need to mess around with these until you get the actual the settings that you look for. But with the G codes, what you can do is you can come in here and you can search for the G code G1 E. I think it's E. I'll have to go and look for it in the video. But you can look for the G codes in here and then modify them yourself. You can modify the bed temperature, the head temperature, all of these settings you can do so directly. And what you can do is search for and find all reoccurrences, for example, for the extruder, the retraction rate, and replace all of the settings, because there are multiple ones. In some cases, there are only 1 or 2 settings that you need to go and change. In other cases, because they're generic, but in other cases they will apply to different components, for example. So G-codes, not to be frightened of. I'll come back and do another video around G-codes, but just some things to consider. I'd also recommend you get Notepad++ because it's a much better editor. Plus you could have 2 or 3 different copies open, and you can compare and contrast between the different files. So you might take a standard G-code, have a look at that, and then compare it with your own G-code after Cura as output. So this is a modified version I've done. Alright, that's it for now, guys. Thanks for listening.